So this question you might have faced at your work or during the interview process. What is hallucination in large language models? And more importantly, how do we control it in production systems? Let's answer this clearly step by step. Hallucination happens when a language model generates information that is factually incorrect, fabricated, not supported by training data, or not grounded in any external source. And the key problem? It presents that information with high confidence. Large language models are trained using next token predictions. They learn statistical patterns from massive corpora of text. They do not query a database by default, check facts, validate citations, understand truth in a symbolic way. They optimize for what is the most likely next word given the context. That means if a fake citation looks statistically plausible, it may generate it. If a made-up explanation fits linguistic pattern, it may output it. Fluency is optimized, truth is not explicitly enforced. And that's why hallucination is a structural property, not just a bug. So now let's talk about control mechanism. We will go through 5 major techniques, but in a practical detail. Number 1, Retrieval-Augmented Generation, RAG. The core idea is don't rely completely on model memory. Give it access to external trusted documents at runtime. So how it works? User asks a question. The system embeds the question into a vector. It searches a vector database, as for example, policy documents, product manuals, or legal documents. It retrieves top key relevant chunks, insert those chunks into the prompt, and the model generate answer grounded in retrieved text. Now the model isn't guessing, it's conditioning on real source material. Why it reduces hallucination? Because the model is constrained to answer based on retrieved context, actual document, and verifiable text. If the answer isn't the document, it is less likely to fabricate. So the production tip is add instructions like if the answer is not in the provided context, say I don't know. This drastically improves reliability. Solution number 2, source enforcement and citation requirement. So even with RAG, models can still fabricate connections. So we enforce structure. Instead of answer the question, we say answer the question and cite supporting document IDs. For example, output format is answer, supporting document ID, and direct quotes. If the model cannot attach a real document reference, the response is rejected. This forces grounded reasoning, traceability, auditability. In enterprise system, this is critical. No citation, automatic fail. Solution 3, constrained decoding and output validation. Most hallucination worsen in free-form generation. So we constrain the output space. Using the techniques like A, structured output, a JSON schema, in which instead of a free-form text, now the model separates claim, evidence, and confidence, which forces internal reasoning separation. Technique B, logit bias and token restrictions. In some applications, restrict allowable vocabulary or ban speculative phrases, or force answer categories. Example, customer support bot can only select from approved product policies or predefined response templates. The smaller the output space, the lower the hallucination risk. Technique number 3, post-generation fact-checking. So the pipeline includes model generates answer, secondary model verifies the claim, cross-check against the database, and if mismatch, regenerate. This regenerate then verify architecture reduces hallucinations significantly. And technique number 4, reinforcement learning from human feedback. So pre-trained models are optimized for likelihood. RLHF adjusts the behavior towards helpfulness, truthfulness, harmlessness. Here how it works. Model generates multiple candidate answers. Human annotates rank them. A reward model learns preference pattern, and policy optimizes and adjusts the model. If human consistently prefers accurate answers, admitted uncertainty, refusal when unsure, the model internalizes those preferences. Technique number 5, self-verification, multi-pass reasoning. Single pass generation is fragile, so we use multi-step reasoning pipeline. For an example, in step 1, we generate answer. In step 2, we extract factual claims. In step 3, we verify each claim. And in step 4, we regenerate answer if needed. So you can even use the same model for verification by prompting. List all factual claims in the previous answer and check if they are supported by the context. This creates internal critic loop. Research shows multi-pass verification can significantly reduce hallucination, especially in knowledge-intensive tasks. So there are some additional advanced techniques which we can use. For example, temperature control. Lower temperature means less randomness, fewer hallucination. Number 2, domain fine-tuning. So fine-tune on curated high-quality domain-specific data sets, which also minimize or reduces the hallucination. Number 3, maximize tool use or function callings. So instead of answering questions directly from a memory, call a calculator API, or instead of guessing dates, call a knowledge API. And so this shift from predict to compute. So the key takeaways: hallucination is not random. It emerges from probabilistic training, lack of grounding, unconstrained decoding, and single pass generation. And it is controlled through layered defenses: grounding, structural enforcement, validation pipeline, alignment training, and multi-pass verification. The solution is architectural, not just prompt engineering. So if you treat LLM like oracles, they will hallucinate. If you treat them like probabilistic generator that need grounding, structure, and validation, they become reliable component in production system. That's the difference between a demo and an enterprise grade AI system.